Good morning. So we will continue our discussion about tokens. So whatever we have discussed till now is what is a token. So token are the smallest component a compiler can understand. Okay, whatever we discussed about different type of tokens like keywords, identifiers, constants, strings, special symbols, operators we have been discussing about the operators, where we discussed about unary operator is plus plus operator and minus minus operator. Then binary operators are there. Arithmetic operators, in the case of binary operator we discussed about arithmetic operators, relational operators, then the logical operators. Now we will discuss about the bitwise operators. Okay, so what is a bitwise operator? Before studying about bitwise operator, let's go through how to convert a number to binary. Suppose I have a number. I have a number 10. I want to find out the corresponding binary equivalent of this number. So what I have to do is I will just divide it by 2. Okay. So what I will get 5, and its remainder will be 0. Okay. Then 5 will be again divided by 2. So what I will get 2, and the remainder will be 1. Again I will divide by 2. So what I will get 1, and the remainder will be 0. Okay, then I will read from bottom to top. So what will be the result? Result will be 1 0 1 0. That is the corresponding binary equivalent. So next thing is we will come back to our problem. So this is a method for converting to binary equivalent. So we are going to discuss about bitwise operator. So the difference between logical bitwise operators works on bits and perform bit by bit operations. So it perform in bit by bit operation. Okay. So that's why I introduce how to convert a number to a binary. So it will be processing the data in bits. Okay, the bitwise operators are and, or, not, not, XOR, negation, left shift and right shift. So these are the bitwise operators. So we have already discussed about AND operator, OR operator and NOT operator. But here the AND operator and OR operator of the above discussed thing is different. So in the case of logical operator, what it gives is it gives either true or false. So it will say if it is true or false. But here it is different. It will return a number. So while by processing we will get a number, not an answer either it is true or false. So that is the difference between bitwise operator and logical operator. In the case of logical operator, what the result will be either true or false. But in the case of bitwise operator, it is performing the operation in numbers. Okay, we will be performing the operation in numbers, and so we will get a result in as a number. So that's the difference. So we will go through this bitwise operator. First bitwise operator is AND operator. It's called the binary AND operator. Okay, earlier when we are discussing about logical operator, double AND is called logical AND operator. Okay, so here what's the difference is that binary AND operator copies a bit to the result if it exists in both operands. So if it exists in both operands, then that means if both are true, then it will return true. That's the same thing. So I will show you an example. Let's say take an example. I have a number 4. I'm performing AND with 5. First thing I want to do is I want to convert this 4 to corresponding binary. So what I will get is I will get 100, 100, and 5 will be 105, 101. So if I want to perform the AND operation of these two, what I will do is that it will check whether both entries are true. Both entries are true. Then the result will be also true. Here both entries are 0, so the result will be 0. Here both entries are not same, it's different. Then 0 and 1, it's AND is 0. So what I will get is the result is 4. 4 is the corresponding result. Okay. So 4 will be the corresponding value. So if I perform 4 bitwise AND of 5, then the result will be 4. The result will be 4. So that is bitwise AND operator. So the only thing is that it is processing in bitwise and we will get a result. In the earlier case, it is checking whether it is true or false using the operand values. Okay, it is returning true or false. But here we are getting a value. So that is bitwise AND operator. Next is bitwise OR operator. So we'll come to that. Bitwise is called bitwise binary or binary operator. Binary OR operator copies a bit if exists in either operands. So same as OR operator. So we'll check that. I want to perform 4 or 5. What is the result? So 4's binary is 100 and 5's binary is 101. It will be divided, not division. Both are 1, so it will result in 1. Both are 0, it will result in 0. Both are either 0 and 1, that it will result in 1. So the answer will be again 5. So this will be the answer, 5. 5 will be this is the corresponding binary equivalent of the bitwise operator. It's a 5. So this is the bitwise or binary OR operator, binary bitwise operator, binary OR operator. Now we will go through the XOR operator. Binary XOR operator copies the bit if it is set in one operand but not on both. So if it is available both 1 1, then it will return 0. Both 0 0, it will also return 0. If it is 1 0 or 0 1, it will return 1. So that is binary XOR operator. So if I perform binary XOR operator, what I will get, I will check that. 4 XOR 5. So what is the answer? So I want to check that. 4 its binary is 100 and 5 binary is 101. I want to perform the operation. So both are 1, then that means it's 0. It's both are 0, then that's 0. And both are 1, it's 0 and 1. So that is the result will be 1. So 0 0 1, its corresponding decimal equivalent is 1. So if I perform 4 XOR 5, I will get the result as 1. This is the binary XOR operator. Okay. Next one is negation operator, similar to the logical operator, but only difference is that there it is negating the value. If it is true, then it will be then we will get false. But here it is not, it is negating the bits. Bits will be negated. Okay. Binary ones complement operator is a unary operator. It's actually not belong to this group. It should belong to the unary operator. It's not a binary operator. It's a binary ones complement operator. It's a unary operator and has the effect of flipping the bits. So it's a unary operator. So we can place this operator here itself. The unary operator we have been discussing, plus plus and minus minus. Similarly, we can place this negation operator there. It's a binary ones complement operator. It flips the elements. We'll check that. So negation tilt symbol is there. Negation of 4. So what is the answer? So what I will do is I will take the binary of 4 and I will flip the value. So 0 become 1 and 1 become 0 1. So the answer will be is 3. 0, 1, 3 is 3. So the result will be 3. So again we are getting a result, not a true or false answer. So that is binary ones complement tilt operator. It's a ones complement operator or negation operator. It flips the bits. Next is left shift and right shift. So actually the thing is that left shift will shift the bits left side and right shift will shift the bits right side. It's a binary operator itself. First we will take the left shift. 2 left shift 1 time. What it means is that I want to shift the number 2, or I will take the number 4 itself. 4 I want to shift 1 time. What it means is that I have the binary equivalent of 4 is 100. So what I will do is I will shift the operator. This value, this 0 will be shifted to the left side. Okay. The second 0, this 0 will be shifted to the second position. And the last position is empty, where I will place it as 0. This is the operation of left shift. Okay, and this is the operation of the left shift. So the result I will get is 1 will be shifted out and 0 will be moved. I will show you one more example. Here I am using only 3 bits. Suppose I am using 4 bits. What will be the result? I can add 4 bits. This is also 4. So in your computer, sometimes you will be using a 32-bit processor. Sometimes you will be using a 64-bit processor. What I mean is that how the numbers will be represented. If I am using a 64-bit processor, the bit size will be 64. Okay. For simplicity, I am saying, okay, I am going to use an 8-bit processor. 1, 2, 3, 4, 5, 6, 7, and 8-bit. I am using an 8-bit processor. I am doing the same operation. Here what happens is that, so 0, 0, 0, 0, and this 1 will be shifted to the left side, 1, and 0, 0, 0. So this will be the answer. Okay. So if I shifted again, if for this number, this minute. Okay, this number, what is this number? This number is 4. What is this number? This number is 8. So how to find out that? There is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 cube. 2 cube is 8. So I get 8. That is, if I shift the number 1 time, I am getting it as 8. Suppose I am trying to shift a number 2 times. Left shift. Again, I am doing the same operation, left shift 2 times. But we will check the result. So this is a binary equivalent of 4. So I am shifting it 2 times. So 0, 0, 0, 0. So not 0. This 1 should be shifted 2 times. So 1 will be moved here. Remaining all are zeros. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So what is this? This is 2 raised to 4. 16. So it's 16. So we are getting the result as 16. So if I shift 1 time, it's same as 4 is been multiplied with 4 is been multiplied with 2. 4 2s are 8. If I shift 2 times, What it means is that this 4 is being multiplied with 2 square. 2 square. That is 4 into 4, 16. If I am doing it again, we'll see that again. If I am doing the same operation, 4 is being shifted, left shifted 3 times. So what is the result? What is the result going to be? It will be 32. It's equivalent to 4 is being multiplied by 2 cube. So it's 32. 2 cube is 8. 4 will be multiplied with, this is equivalent to 4 is multiplied by 2 cube. It is a 8 4s are 32. So I will get 32. So that is left shift is actually a multiplication of 2's power. So if you want to perform a multiplication of 2's power, instead of doing the multiplication of 2's power, because getting power, finding the power is very difficult. It is a time consuming process. Instead of that, we will simply convert that to a binary, and this number will be automatically shifted 3 times. I will get the corresponding power. So the only problem I face is that once this one, in this case, if this one reaches the last point, the bit size will be there. Here the bit size is 8. If it reaches beyond 8, the value will be 0. That's the only difference. Up to that, this process will be continued. After that, we will get 0. Okay. That happens in the earlier case. I try to, this is my number, 4. I shifted 1 time. If I am representing it is using 3 bits, what happens is that automatically it becomes 0. So that's the only problem. The bit size is very large. Normally we will represent the bit size as 32 bit or 64 bit. So we can do this operation very fastly. Okay. So we can even complete 2 raised 64 operations easily by shifting the 2 raised 63. Instead of finding 2 raised 63, I can simply shift the operator, and the computer can perform it very fast. So that is our left shift. Okay. So left shift operator, binary left shift operator, the left operand value is moved by left by the number of bits specified by the right operand. Okay. Similarly, we have the binary right shift operator. The left operand value is moved right to the number of bits specified by the right operand. So another thing. So we will check that. So the same thing. I want to perform right shift. A right shift of 1 time. What happens? So we will take the this is my number 4. If I right shifted, what happens is that this 1 will be shifted towards the right. So 1 is here. This will be the result. Okay. So this is 4 and this is 2. Okay. If I shift it 2 times, if I am shifting it 2 times, what happens? So if I am performing the same operation 2 times, 4 is here, again shifted 2 times. What happens is this 1 is being shifted. This 1 is being shifted 2 times. So what I will get 0 0 1. So this is 4 and this becomes 1. Here also the same problem occurs. If you shift it again, the value becomes 0. But what is happening here? Here it is. This is 4. If I shift it 1 time, it's equivalent to a number divided by 2. This is equivalent to that number divided by 2 square. Okay. So instead of dividing by 2, we can use this right shift operator for doing the operation. So that's also an advantage. So division is also time consuming. Instead of that, the computer will use this operator, this logical bitwise operators for performing the operation. So these two are very important operators, left shift and right shift operators. As the size of the bit is very large, we can easily process bits. So this is a binary left shift and binary right shift operator, which has been used heavily by the computer. Okay, so this is a binary operator. Next is the assignment operator. So we have already discussed, okay, assignment is there, A equal to B. So assignment operator means we can combine other operators with the assignment operator. Same thing, minus equal to. What does it mean? Instead of writing minus, instead of doing this operation, if I want to write like this, A equal to, I want to perform a minus operation. Instead of writing A minus B, what I can write is that A minus equal to B. The same. That is the assignment operator. Assignment operator is like this, A minus equal to B. So like that, we have other operators. We will see that this is a plus operator. Plus equal to. This is a simple equal to, simple assignment operator assigns a value from right to left to the left hand side. This is plus minus, minus equal to, star minus, divide equal to, mod. Then left shift and right shift and or and bitwise. So we'll see that. We will see the examples. First is simple assignment operator, A equal to B. This is simple assignment operator. Instead of A equal to A minus B, I can write like this, A minus equal to B. Like that. Similarly, A equal to A plus B. I can write that as A plus equal to B. The same thing will happen. Okay. So similarly, if I want to perform A equal to A into B, instead of that, I can write it as A into equal to B. Similarly, division A equal to A divided by B. Instead of that, we can write it as A divided equal to B. Okay, like that, A equal to A mod B can be written as A mod equal to B. Same. Similarly, we can use shift operators. Left shift and right shift here also. Instead of writing A equal to A left shift 2, I can write like this, A left shift equal to 2. Both are same. Similarly, right shift, A equal to A right shift 2, it can be written as A right shift equal to 2. So that is a right shift operator and can be used. So instead of finding trying to write A equal to A and B, can be rewritten as A and equal to B. Like that, or A equal to A or B can be rewritten as A or equal to B. You can write like that. Then XOR, bitwise exclusive OR is there. Same thing, A equal to A XOR B can be written as A XOR equal to B. So it's easy to write. So if you need only, you can use. If you know the concept only, you can use this. Simply we can write. So this is the binary operators. So binary operators are arithmetic operators, relational operators, logical operators, bitwise operators, and the assignment operators. So all these are binary operators. Next is a third type. It's actually a ternary operator. So it's called the conditional operator. So here we can have three operands. They are ternary. So expression 1 and expression 2 colon expression 3. As they require three operands, they are called ternary operator. What it means? I will show you. This is a conditional operator. So this can be used instead of if. If I want to check A is greater than B, I will write like this: if A is greater than B. Okay, I will write like this. Then I will write A is greater. A is greater. Else B is greater. B is greater. I will use a printf here. Then quotes I'm writing this. Here also. So I'm checking the condition whether A is greater than B or B is greater than. So instead of this, I can use this ternary operator. How? I can write like this: A greater than B. Simply I will write like this. Okay. So the operation is A. This is expression 1. Okay. If it is true, A greater than B, then I will ask a question. If it is true, then I will write printf A is greater. A is greater. Okay. So that is expression 2. Then I can add another expression, colon printf B is greater. B is. So we can write this whole sentence using this. So mostly we will not be using this because we know we are familiar with if it's more easy. But if somebody is asking, is there a ternary operator in C? Yes, there is. This is a conditional operator, which using that we can check the conditions. We can use multiple conditions and operator can be combined. Everything can be combined. Only thing is we will use this as a format. First expression should be written. Anything you can write. If I want to check A greater than B and A greater than C, you can use A greater than B and A greater than C. Same condition. Then we will add a question mark. Then the true statement will be written here. After that we will give a colon. Then a false statement will be written. So the compiler will check this condition, whatever condition you can write. If the condition true is condition 1 is correct, then expression 2 will be expression 2 will be executed. Otherwise expression 3 will be executed. So that's the thing. This is a ternary operator. Ternary operator. Then other operators are also there. Size is actually size is SIZE, size of operator. It will return the size of a variable. So I want to check the size of the integer variable. I can use this operator, size of. You will see that. Then AND is there. It's used to return the address of the variable. We have been using that. In the case of scanf, we have been using this ampersand symbol. Ampersand. Star is a pointer to a variable. It's a pointer to the variable. So these are the operators, other operators. So these are the tokens available in C. So what we have discussed till now is the tokens. So we can identify the tokens as a component which a compiler will understand. So keywords are there, set of keywords are there, and identifiers will be there. It's used for naming the variables, function names, array names, etc. And constants are there. Constants we create a constant variables created using the keyword const. Then strings are there. It's a collection of characters and ending with a special symbol /0. And then special symbols are there. A lot of symbols are there. And then we comes to study about operators. What we understand is that there are different type of operators: unary operator, plus plus, minus minus, then negation operator. All that are unary operators. Even -2, where that minus, if I am writing a -2, that negative is a unary operator. +2, That plus is actually not an addition, it indicates a positive number. That plus is a unary operator. Then binary operators, where we discussed about arithmetic operator, relational operators, logical operators, bitwise operators, and then assignment operators. So these are all operators, assignment operators. Then for ternary, that much are binary operators. Then in the case of ternary operator, we have the conditional operator. And finally, we discussed about the special type of operators available. So these are the tokens available in C. Thank you.